Okay, I'm going to use a die example to help you with this lab. I'm going to simulate rolling a single die 200 times and have the output stored in column 1. So as review, to do that, I'm going to click on Data, Simulate Data, Discrete Uniform. I'm going to do 200 rows. In other words, I'm rolling this single die 200 times in one column. The minimum value will be 1, the maximum value will be 6. Okay, so I'm going to click on Simulate, close out this window, and you'll see that the first column is replaced with integers that fall between 1 and 6 inclusive. So this is an example of rolling a single die 200 times. So what I'm going to do next is I'm going to take a look at the histogram. Okay, I need to choose the column and create the graph. Because I'm simulating rolling a single die, a fair die, I should expect my histogram to look fairly uniform, and it does. I can also go ahead and run the summary statistics on this, and you're required to do that for your lab. Okay, so summary statistics for this single column. Okay, so I can go ahead and get the summary statistics for that single column. Again, that's a review. Now I'm going to go ahead and delete this column because the next thing I want to do is I want to simulate rolling 2 dice 200 times, and then I want to find the average of each outcome and then find the descriptive statistics on that. In other words, we're creating a sampling distribution, and we're going to use that to verify the results of the central limit theorem. So what I'm going to do is I'm going to click on Data, again, Simulate Data, and again, Discrete Uniform. Okay, I still want 200 rows. This time I'm going to choose 2 columns. Minimum value is 1, maximum value is 6. Okay, now in your previous lab you were interested in what the sum of the faces was. What you're looking at now in this lab is you're going to take the average of the outcomes. In other words, for this first row you want to sum 1 and 2 and divide by 2, and then sum 4 and 6 and then divide by 2, and so on. Okay, so we're going to have the software do that for us. So what we're going to do is we're going to click on Stat and scroll down to Summary Statistics, and this time choose Rows. Okay, so I want to select the 2 columns that I have, because I'm basically asking the software to average each row in both of those columns. And I want to click on Next because what I'm interested in only is the mean. So I'm going to take out, by double clicking, all of the other statistics that I don't want. Whoops, it put it in there twice. Sorry about that. Don't double click. Okay, word of warning. Okay, so I need to take these all out. Okay, so you'll notice in the gray field all that I have is the mean. Now what you need to do next, this is important, you need to click Store Output in Data Table because you want all of those row means to be stored in that third column. Okay, so I'm going to Calculate, and I need to click that window closed, and you'll see that now I've created a column of the average of the first 2 columns. Okay, so what I'm interested in next is to take a look at that histogram. Okay, so I'm going to go to Graphics, click on Histogram. Now I want to do that histogram on that third column titled Row Means. Okay, already notice that the histogram is a lot more bell-shaped than the previous histogram of the single column. This is one of the results that's guaranteed by the central limit theorem. Let's take a look at the summary statistics. Okay, I'm going to click Summary Statistics and then click on Column, because this time I want to take a look at the mean for this column of row means. Okay, so looking at the mean of the row means, that should be fairly close to what you got when you ran your summary statistics on that single column. Okay, but you'll notice that the standard deviation is going to be different, and that is a result guaranteed by the central limit theorem. You will need to actually identify the change with respect to what the theorem states in your lab. Okay, so I'm going to go ahead and delete these columns. Okay, delete all 3 of these, or you can open up a new blank data table if you like. Okay, so I'm deleting all of those. In your lab, I have you do this experiment repeatedly, with first averaging 2 rows and then 5 rows. I'm sorry, first with 2 columns and then with 5 columns and so on. I'm going to go ahead and jump to simulating rolling the die 200 times, and I'm going to do this for 10 of the columns. And then I'm going to create the 11th column to be the column of the row means. Okay, so again, I'm going to click on Data, Simulate Data, Discrete Uniform. Okay, this time I'm still doing 200 rows, but I want 10 columns. Now in your lab, you're going to be generating 500 rows. Okay, my minimum value is 1, my maximum value is 6, and I'm going to simulate. Okay, so each of these columns represents rolling a die 200 times. Okay, so I want to have the software average the values in each row for me so that I get this 11th column to be a column of row means. Okay, so to do that, again, I'm going to go to Stat, and then Summary Statistics, and then Rows. I need to tell it what my columns are. Okay, I want to do all 9 of them. I'm sorry, 10 of them. A little tired, can't count today. Okay, and then again I'm going to click on Next, and I want to unclick the statistics that I don't want. I don't want to clutter up my data window. Okay, so I just want to create a column of row means, and again, this is important, you need to click on Store Output in the data table. Okay, so click on Calculate. This is really annoying, I'm sorry about this. You close that. Okay, so you're going to see that the software went ahead and averaged all 10 values in each row. In other words, the software for each row added up the values and divided by 10. Now I'm concerned with the distribution of the row means. So again, I'm going to look at the histogram. And I should expect the histogram of the row means to be very bell-shaped. And there's the row means generated by those 10 columns of 200 values. Okay, the next thing I'm going to do is just take a quick look at the summary statistics. Okay, I'm going to do that on the column of row means. And in your lab, you need to identify the summary statistics and how that supports the conclusions in the central limit theorem. Now, in your first problem in the lab, I have you randomly generating 800 integers between 0 and 9. Okay, so that's not like rolling a single die, a single six-sided die, but the process is going to be similar to this. This example I did was a shortened version of the second problem in your lab.